Now, one thing I want to mention in this video are sets of numbers. Let me just write that down. Sets of numbers. So there are a number of the sets of numbers, and example one are rational numbers. Rational numbers. Rational numbers. Number two are natural numbers. Natural numbers, or put that in this. Or counting numbers. Counting numbers. Okay, sets of numbers. We've got rational numbers, whole numbers, natural numbers, or counting numbers, and integers. So, what are rational numbers? Rational numbers are numbers that can be expressed in the term A over B, the condition that B is not equal to 0, because that would be undefined, is not equal to 0, and A and B should be members of integers. So the symbol for rational numbers is this capital Q like symbol. Okay, and yes, that's it for rational numbers. We'll go deeper into rational numbers because that's the next topic. And natural numbers is simply counting numbers. So this is 1, 2, 3, 4, up to infinity, 4, 5, 6, 7. So that's what I call counting numbers, because people usually start counting from 1, 2, 3. It's rare you hear people say 0, 1. Now when someone starts from 0, now these are whole numbers: 0, 1, 2, up to infinity. And the symbol for this is simply W like that. Symbol for natural numbers is this symbol, like something like this. Okay. And integers simply start from negatives: -2, -3, -3. So integers just are simply whole numbers that include negatives. So how can we simplify this? So we can say okay, integers, like I was saying, integers simply negatives. For negatives and positives, all these are from negative infinity to positive infinity, 1 million, negative 1 million, to all these are integers. And yes, whole numbers, like I said, 1 is starting from 0, 1, 2, 3. And also, well, if we have rational numbers, we also have irrational numbers. So irrational numbers. Okay.
irrational, and these are simply the opposite of rational numbers. So we said rational numbers are numbers that can be expressed in the form a over b. So irrational numbers simply are the exact opposite. These are numbers that cannot be expressed in a, so cannot be expressed in the form a over b or a over b. Okay, exact opposite of rational numbers. So we'll go into details, using the details of rational and irrational numbers. So one thing we need to know is when you unite rational, so you rational unite it with irrational, that's where the symbol for irrational numbers is this. So when we do this, what we get are real numbers. So let's do that again. What we get are real numbers, because if you look at it, we do this, you can get a clean space there. Okay, so as I was saying, q unite with rational should be equal to real numbers, and q intersect with real numbers is an empty set, because there's nothing common between rational and irrational numbers. But when you combine them, you get all the real numbers, because natural numbers are members of whole numbers. So whole numbers, you get this one, and whole numbers are, or let me use subset. Then I think it's better as a subset. Included this. So natural numbers are subsets of whole numbers, and whole numbers are subsets of integers. And integers are subsets of rational numbers. So technically everything here is found in a rational number. Then whole number and natural numbers are found in integers. Natural numbers are found in whole numbers. So that's what I was saying. If you combine natural numbers with irrational numbers, you get real numbers. So real numbers. So this is technically every single number. So in the next video we will go into details of real numbers. Then the other video will go into details of irrational numbers. So again, I'm going to emphasize that I am following topic by topic, so pay attention and make sure you take note of exactly how I'm going, and observe how your lectures will be also moving, because you find that they're similar with what I'm doing. So subscribe and you'll be updated with everything, and see you in the next video.